All right, today we're going to be looking at section 1.2 in Precal. This is functions and graphs. Here we can see the learning objectives. We're going to determine whether a correspondence is a relation or a function. We're going to find function values, outputs using a formula or graph. We're going to graph functions. We're going to determine whether a graph is that of a function. We're going to find the domain and range of a function and then solve some problems using functions. Okay, so here we have functions section. You have a little example here where they explain a little bit about functions. You can kind of see we use ordered pairs. So we have X column, a Y column, and then they put the two together, and then they have a correspondence. So how one relates to the other, or the relationship between them. Okay, so let me move this. And I'm just kind of giving an overview. So we're going a little bit more to describe what's an example of a function. And there are several terms that will allow you to identify the X or the Y. So here, it says where X is the independent variable, so and then it says Y is the dependent variable, so those are other names to relate to X and Y. Here's a set description of a correspondence or relationship. You have a first set and then a second set and then how they correspond. So the first set is called the domain. Again, that's referring to X. And then the second set is called the range, again referring to Y. So you've already seen two terms. You have independent and dependent, and then you also have domain and range. It says for each element in the domain, there is exactly one member in the range which corresponds to it. That is the definition of a function. So here it is again. A function is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to exactly one member. So that means you can kind of see this drawing here. -6 corresponds to 36, only one term, and 6 corresponds to 36. There's an example here with presidents and the Supreme Court justice that they have appointed. George W. Bush appointed Clarence Thomas. He only appointed one. But here William Jefferson appointed 2 Supreme Court justices. So the fact that he has 2 lines coming from his name, or he has appointed 2 different Supreme Court justices, that would cause this relation not to be a function. So this would not be a function. Each time you see the first set only having 1 line each, then it would be a function. Okay, so you have some more examples, and the explanation explain, the solution explained here. So just more examples. Definition of a relation. I think this should have come before function, but a relation is a correspondence between the first set called the domain and the second set called the range, such that each member of the domain corresponds to at least one. So in this case, a relation, they can correspond to more than one, but a function will only correspond to one exactly. So just more definitions, more examples and explanation of that. You have a set of ordered pairs, and we describe if it's a function or if the relation is a function or not. And so you have ABC, and then they have the solutions here explained. So just some examples to kind of help you really grasp what's going on here. Then we have notation for functions. So we used to have y equals, and sometimes we'll still have a function in terms of y equal, but then we'll use function notation, which we'll use like f of x. So you see this here, f parentheses x is read f of x, or f at x. So instead of having a y equals equation like so, they will replace y with this f of x. And then where we have the x's, those are the independent, those are what we input. So we have this y equals, the inputs are members of the domain or x value, so a third term to describe that, and then the outputs are the range, the y values. So you input some x, you solve it, you get out a y value. Input, output. So we'll see some more examples of that. So now you see this function notation f of -2 coming from this equation. They plug it in and they solve it. So they give you a little bit more explanation and some problems to solve. And then we have graphs. So you can make a graph by picking any inputs and then plotting the outputs or the ordered pairs together. So you pick whatever you want to plug in for x. We're going to sketch the graph, and then once we sketch it, we can match up the graph to the equation. But the general way to do that is to plug in some points. And so you have several different examples of graphs here, which we'll do a little bit more hands-on once we get into my math lab. And so again, just the definitions and then the examples and the solutions here explained. So do take some time to go over that. So here we have the vertical line test. This is helping you to determine if a graph is a function. So if you draw a vertical line and it crosses more than once, then the graph is not a function. Otherwise, it is. So you have some examples here, and then you have the solutions. A would be a function because no vertical line would cross more than once. B is not a function. You can see that blue line crossing 3 times. As for C and D, same thing, and then the others are functions. And then we're going to talk about domain and range, how to find it. So this, I'll give you more notes of this in the problem solving with my math lab. But there are 3 scenarios that we look for mainly. We look for a fraction with a variable in the denominator that will cause us to have restrictions. We look for square roots, namely even roots. So we would have a problem here because we can't have a negative under a square root. However, when you have something like D, a third root, then we can still use any variable because you can have a negative under a square root. Under a cube root or odd power. So no negatives under an even root, but you can have negatives under an odd root. So, and then you have solutions explained, which we'll work these out. I'll work some out for you in my math lab, but this is just an overview. If you have a break in your sets, they connect them using this U symbol, no tail. It's called the union or inclusion of both sets. So you have one on the left, one on the right. So just for example, A, we can't divide by 0, and the number that would cause this to be 0 is a 7. So if you plug the 7 here, you would be dividing by 0, and this wouldn't work. So the way that we correct that or show the domain is think about if you had a number line from negative infinity going all the way to positive. You would remove one number, the number 7. That's the only number that doesn't work. That would break your number line into 2 halves, which I'll show you again when we do my math lab. But we'll have 2 sides, one from negative infinity going as close to 7 as we can, and then jumping on the other side of 7 going to infinity. So that's what this means here. And then we just have some graphs where we want to visualize domain and range, where we can see it, and then we write out domain and range from the graph. So again, like from a number line, this solid circle means that point is included. So they use a bracket here, a square bracket. And we start at -4. So this graph goes from -4 all the way over until it gets to 3. And it's a parentheses because it has an open circle, means 3 is not included. So this is domain, and then we do the range the same way. We look top to bottom. You always want to start your domain and range with the lowest point and go up to the highest point. And again, we will do some of these in my math lab. And they give you solutions for those. And then we'll do some applications. So we'll have some word problems, and we'll just apply some of the things that we've learned. And then, of course, you also have some practice problems in the textbook. Okay, Without going on too much more, we're going to go ahead and jump over in my math lab and start working some examples.